So we're on day 2 of compound inequalities. And just to recall from yesterday's notes, compound inequalities with and must satisfy both. Remember, this is the snob. And is the snob. You have to be just like them in order to be a part of it. And then or, remember, is the friendly one. So you just must satisfy either one of them, and we'll take you in. Not a problem, okay? So just to remember, and is both snob. Okay, that's a snob. You have to be just like them, where or is either one. Now we're just going to solve some more inequalities, and as it says, we're going to say something a little different. But you'd hope if we're going to do a second day on it, we should do something a little different. So let's solve these. Now, again, my recommendation is to divide them into sections, okay? And then cover up part and say, how would I start this equation? Well, we know that we're going to move that 7, so we're going to subtract 7 from both sides. But we have sections, so we have to do it from everything now. So now we have negative 8 is greater than 4x, which is greater than or equal to 4. Yes. Once again, we're going to do it to the different regions. So we're going to divide through by 4, divide by 4, divide by 4. And we get negative 2 is greater than x, which is greater than or equal to 1. Okay. Now, let's just think for a second on this one. Negative 2 is greater than x, which is greater than or equal to 1. If I were to graph this, here is negative 2, and here is 1. Okay? Could I also well, it's going from lowest to highest. So here, do this on this one. Negative 2 is greater than 1. Is that true? Can I have negative 2 being greater than 1? No. So there's no way to graph this one. This one is no solution. Okay, there is no numbers that will satisfy that. So if I, just so that you can see, if I would plug in, let's pretend like it's in between. Let's plug in 0. Negative 2 is greater than 0, which is greater than or equal to 1. Well, that's false. So see how you can kind of check yourself. So that one's just no solution. We can't write anything on that one. Sometimes, because it is set notation, for set notation, we could put empty set. But interval notation, it just doesn't work. So here we go with or, and remember with or, just solve each inequality. So we're going to solve this one here. We add 3 to both sides. We get 5x is less than 10. We divide both sides by 5. And we get x is less than 2. Solve this one, and we add 6 to both sides. So we get 4x is greater than negative 4. Divide by 4, and we get x is greater than negative 1. Okay, and this is an or. So either this one works, or this one works, or they both do. We just have to have one that works, and we're good. So let's graph. X is less than 2, so we have a 2, and we have a negative 1. X is less than 2, open circle, going left. And x is greater than negative 1. Well, this is not an and, this is an or, so we're not looking, we're just saying it's one or the other. But look, if I take one or the other, it is everything there. So this is from negative infinity to infinity. Okay? And standard form, we don't really talk about, would probably just go, hey, that's standard form. Good. Let's see what happens on number 3. Now here they gave us 2 separate ones, we're just going to go ahead and write it that way. I will tell you, we could have, well, I'll show you that at the end. Okay, so subtract 3 from both sides. We get x is less than negative 2. And subtract 3 from both sides. And we get x is greater than or equal to, is that 3? So let's graph that. Oops. So that you can see what the difference is. X is less than negative 2. And then we have the 3. 3 is a closed circle going to the right. On the negative 2, it's an open circle going to the left. This is an and. Remember, and has to satisfy both. It has to be where do they intersect? Where do they intersect? Do they intersect? No, they do not. So this one is also a no solution. There is no number that would satisfy both. So, say for instance, we take 4. 4 is less than negative 2 and 4 is greater than 3. Nope, it's not less than negative 2. So that one's a no solution also. Okay, and number 4, oh, we get to go into different areas. Let's see what happens here. Oh, That was the other thing I was going to tell you. Look at this one right here. See how they both have an x plus 3? You could have just written it as 1 is less than x plus 3, which is less than or equal to 6. But we would have found out that that was not going to work. So that's the reason they wrote it that way originally. Okay, here we go. So we're going to move the 8. We subtract 8. And we get negative 24 is less than negative 3y, which is less than negative 15. Oh, do you see what's coming? Do you see what's coming? We're going to then divide by a negative 3. Did you hear what I said? Divide by a negative! So we get 8 is less than x, which is less than... Oh, wait. Where's my error? Where's my error? There we go. My inequality sign switches. I yelled, and then that distracted me so much I forgot. So 8 is greater than x, which is greater than 5. Okay, so I'm a person who likes to have my lowest one, and look what happens. Okay, so on this one, it actually works out. Even though it goes that direction, I can rewrite it, and I always do. So this was not a big deal. Okay, it's just open circle and open circle, and it's the stuff in between. So this one we can actually write out. There's our standard form. Oh, I changed the variable halfway through. And then our interval form. It looks like this. Okay, so make sure you're doing those worksheets, and if you have questions, you know where to find me, and I hope that all works out, and we'll see you soon. Thank you very much.